Okay, this radio station looks like I need to start all over again. Okay, I had to pause it and it went out on me. Okay, so I'm doing wave equation calculations. The first equation is C equals lambda nu. C stands for 3 times 10 to the 8th meters per second. Lambda stands for wavelength. It's always in meters. Nu is frequency. The units are hertz or inverse seconds. Let's say I have a radio station that broadcasts at 88.1 megahertz. All radio stations broadcast in megahertz. And I want to know what is its wavelength. Okay? So the first thing I need to do is, to get the megahertz into hertz. So I take the 88.1 megahertz and I'm converting it to hertz. Just so happens that they are 10 to the 6 hertz in 1 megahertz. So I do the calculation. 88.1 times 10 raised to the 6th power. And I don't like it in regular notation, so I'm going to switch it over to scientific. And we get 8.81 times 10 to the 7th. We are now ready to do the wavelength. So I plug it into this equation right here. 3 times 10 to the 8th equals my x, that's what I'm solving for, times 8.81 times 10 to the 7th. Now, to solve for my x, I'm going to divide both sides by the frequency. Here's a little hint. You always have c on top. Doesn't matter if you've got wavelength or frequency, you always divide it into c. So I do 3 times 10 to the 8th divided by that answer right there. And I get 3.40 or 3.41. This is wavelength, so it always comes out in its correct unit of meter. Had this been wavelength and solving for frequency, the math is still the same, but it comes out in hertz. Now the other wave equation is E equals H times frequency. All right, this is frequency. H is always 6.626 times 10 to the negative 34th. It's in joules seconds. Your energy is going to come out in joules. Now, let's take the frequency that I have up here, okay, and use it to calculate energy. So I have 6.626 times 10 to the negative 34th times 8.81 times 10 to the 7th. And I get 5.84 times 10 to the negative 26 joules. Now this is joules per electron. Atoms have billions upon trillions of electrons, so this would actually be a bigger number if you were looking at a sample of an element or a compound. Another problem I could ask you to do. What if I gave you wavelength and I asked you to go find energy? Well, you would do this part first. You would find your frequency and then plug it in to this equation. That would be kind of like a two-step problem right there. All right. Hope this helped. I will post this on YouTube. Good luck tomorrow on your test. Thanks.